All right, so like I said, coordinate geometry. I think the best word that you gave me when I asked you a few words about coordinate geometry, what first pops in your mind? Nothing again? Wait a minute. Sorry, he's not doing nothing. He's not doing nothing. That's what he always tells me anyway. Right? So you must be mistaken. He was being perfectly fine, I guess. Do you believe that one? I don't either. All right. So the word point was really important when you talk about coordinate geometry. All right. So this is what it looked like when we talk about coordinate geometry. All right. Put about right there. Put about right there. That's pretty good. All right. So I'm going to put some points on here. Okay. I'm going to put 3 specific points. I'm going to put, I'll tell you what, I'll list them over here and then I'll draw them. You know what? I'm going to put like a regular graph here instead of, well, I mean, that's a regular graph, but I'm going to put one with the numbers and stuff so we can count, so we can be pretty precise. All right. So it's kind of like having graph paper. Just makes it a little bit more accurate. So let's continue with this. So I'm going to put some points on here. -7, 1. So let's even go to 7. 1, 2, 3, 4, 5, 6, 7, 8. Good. All right. And then point B is 1, -5. And then point C is 7, 3. So what I'm going to do is I'm going to plot all 3 of those points. So if I have 3 points, guess what I'm going to have? We've been talking about it all chapter. What have we been talking about all chapter? Triangles, right? So I'm going to make a triangle out of these 3 points. All right, so that's part of my coordinate geometry of triangles. All right, so let's plot it. -7, 1. So it's 1, 2, 3, 4, 5, 6, 7, 1 would be right there. So there's point A. Point B is 1, -5. So I go over 1 to the right 1 and down 5. 1, 2, 3, 4, 5. That's point B. Then we got point C, which is 7, 3. So it's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, right there. So everybody should be able to at least get that, correct? Now, if we want to make a triangle out of it, sorry, I just cannot lose this cough. So what can I do if I'm going to make a triangle out of it? Do what to these dots? Connect them. Very good. Connect them. So I'll go to there, and then from there to there. And guess what I have? I got a triangle. Very good. All right. And we're going to do something. And I think you know what I should have done? I should have done this other example instead of this one. That's all right. We got time. Let's do them both. All right. So I can figure some stuff out about this particular triangle. Let's do it real quick. What I want to do is figure out the slopes of all 3 of these sides. Okay? Do you remember how to do slope? Wasn't it last chapter? Well, the m is the slope, but y equals mx plus b is not the slope. The m is the slope. So, actually, I don't want to put y equals. Let's put m. M equals, how do we find the slope? Not the equation of the lines. Rise over run. Okay, or what about x's and y's? Yeah, we'll go y2 since that's what we usually did. You can go y1 minus y2. It doesn't make any difference. But as long as you do the y's, you put it on top, and then you do the x's in the same order. So if I went y2 minus y1, I have to go x2 minus x1. Okay, so that's how we did the slope. Remember that? So it's been a while. It's been a chapter, right? We've gone through a whole entire chapter since we've done slope. So let's do that. Let's find the slope of all 3 of these sides. And I want to show you something about that. All right. So let's do, I don't know, which one do you do first? Let's do AB. All right. So let's do AB from here to here. There's my points right there if you want to remember what those points are. So how do I find the slope of AB? Well, I subtract the y's, so I'm doing these two right here. So let's go. It doesn't matter which order you subtract them in, okay, as long as you subtract them in the same order. So you could go -5 minus 1, or you could go 1 minus what? -5. Okay? What do you want to do? Let's go 1 minus -5. Is that all right? 1 minus -5. That's the y's. In the same order, if I went the first one minus the second one, then I'm going to go what? -7 minus 1. Let's see what that is. What's 1 minus a negative? Minus a negative is plus. 1 plus 5 is 6. This is add the opposite. That's -8. Reduce it. What does that reduce? 3/4, but it's negative, right? So put a negative. All right, let's do it again. Let's do, so we did AB. Let's do BC. All right, so we did AB. Let's do BC, and let's find the slope. We're doing the same exact thing, except we're doing it with points B and C this time. These two right here. So again, let's just go the first one minus the second one. Yes. What's that? Where's the 3? What do you mean? Right there, 7 and 3. Huh? I didn't do C right here. I only did AB. So, right, so I didn't have to use C. Now I am going to use C on this one. Whoops. Now I am going to use C because I'm doing BC. So now I'm doing these two. Everybody see that? See this right here? So those are the two I'm doing now. So what do I got? -5 minus 3. And then 1 minus 7. -5 minus 3 is -8. And then 1 minus 7 is -6. Reduce it. 2 goes into both of those. 4/3. It's positive because it's negative over negative. Now, do you see something with AB and BC? This is -3/4. This is positive 4/3. They're negative reciprocals. So what must be true about those two lines then? No, they don't have the same slope. They're completely different. They're perpendicular. That's right. This is -3/4. This is 4/3. They're negative reciprocals of each other. So what could I say about AB and BC? They are what? Perpendicular, which means it forms a right angle. Just by looking at it, you may have guessed that it was a right angle, okay, but you weren't sure. But now we can tell that this is a right angle and this is a what? Right triangle, okay? And that could be very useful, all right, knowing that that's a right triangle sometimes. All right, let's keep going. What's the other side we haven't found the slope of yet? AC, so let's do that. Really, it's not going to make much difference in what we're doing right here. That's what I wanted you to see. I wanted you to see that this and this one were negative reciprocals of each other, which means that AB and BC are perpendicular, which means it's a right angle. Everybody see that? Yeah? Maybe? Maybe not. All right, let's do AC. So we're doing this one and this one. Okay? So let's subtract the y's again. Let's go 1 minus 3. And let's subtract the x's. -7 minus 7. That's -2. That's -14. That is 1/7. Okay. Now, does the 1/7 have anything to do with the other two? Not really. There's no. They're not. It's not equal to any of them. It's just the third side. It's just the slope of the third side. All right. I will do this. Watch this. Slope is 1/7. So watch. See how that point crosses right through that y-axis? Let's go from here to here. Let's actually rise and run from this point to this. So up 1, to the right how many? 1, 2, 3, 4, 5, 6, 7. There it is. 1/7. So it works just like it should, right? Okay, looking at the graph, that's 1/7. If you come over here, look, I'm going to go up 2, 1, 2, and go over how far? -14, okay, or positive. I don't know why I said negative. But up 2 to the right 14. What's 2 over 14? It's 1 over 7, right? So would you agree that that slope is 1 over 7? Yeah, it works perfect on that graph. That's why I use the graph paper so we could count real specifically. All right, so we found the slopes. That's interesting. All right, maybe to you it's not that interesting. To me, it's kind of interesting that we can find out something about this triangle. It doesn't always work out that way. Only works out when you have a right triangle. But there you go. Now you know that that's a right triangle. And that can be really, really helpful. All right, so let's keep that in mind. Let's do this. Let's scooch this up a little bit to about right there. I think we can, let's get rid of this. Don't get rid of it on your notes, but on mine I can get rid of it. All right, and I'm going to take that thing, keep on grabbing the top of that. I'm going to put this over here, give me some room. Now what I'm going to do is this. Now I'm going to find the distance, the length of all 3 of the sides of these triangles. So could I just like count over 1, 2, 3, 4, 5, 6, 7? Can I do that? No, I can't count diagonally like that. All right, so what I'm going to have to do in order to find the length of all 3 of these sides, everybody watching? Something's going on? Yeah, it's usually the middle of it. That's Ben Andrew, by the way. Benjamin Andrew. All right. So look, all 3 sides, what I want to find all 3 sides, the lengths of all 3 sides. Okay? So how do we do that? How would you find the lengths if I am given the points? What do I do? What's the formula? It's not the length formula. What is it? It's the what formula? What's that? Slope. I just found the slope. I'm finding the length this time. I'm not finding the slope. You guys are just throwing out geometry words off the top of your head. You're not even thinking. What is it? I'm trying to find the length from A to C, from A to B, from B to C. What am I finding? Brandon, please bail me out. The distance formula, okay? The distance. Alani, was that you saying it first? Thank you. All right, so we're finding the distance formula. So you got to remember what the distance formula is. Every once in a while in these chapters, this coordinate geometry stuff's going to pop up, and they're going to want you to be able to find the slope and find the distance, okay? Just because we did it in chapter 3 doesn't mean we're never going to see it again. We're seeing it again, all right? And you're going to see it again in Algebra 2 and any other math class that you do. This is a really popular thing to do. So do you remember what the formula is? If not, okay, well, you put all that stuff in there first, right? Remember that? I call it the shell of the equation. No, I do the x's first. Is it minus or plus? It's plus. All right? It is minus. Here I am getting mixed up. It is minus. And then we subtract the y's. Everybody good? Here's your plus right here. That's probably what I was thinking of. All right, so let's put them in. Let's find the distance. We're going to find 3 distances. So let's do AB first. Okay, we'll do the same. So the distance of AB. So let's do it kind of quick. We've been dragging a little bit today. So we're going to put that squared plus that squared. And you take your x's, right, with A and B. You take the x's and you subtract them. So it's negative 7 minus 1. Okay, those are your x's right here. Then you take your y's, y minus negative 5. And let's see what we get. Keep the square root. Don't forget about that. Negative 7 minus 1 is negative 8. Negative 8 squared is 64. Minus negative 5, that's plus. That's 1 plus 5 is 6. 6 squared is 36. 64 plus 36 is, I'll tell you what, let's do it right here. Give us some more room. 64 plus 36 is 100. What's the square root of 100? It's 10. That's right. So what's the length of AB? From here to here. How long is that? It's 10. Okay? Well, doesn't make any difference, does it? 10. Or 10 over 1. All All right. Everybody with me on that? All right, let's do another one. Let's do BC. All right, so we're going to do the same exact thing, the distance of BC. So put it into the distance formula. Now we're doing BC this time, right? This middle one and the third one. So I'm going to put my shell. So we subtract the x's for B and C, all right? These two right here. So it's 1 minus 7. Then we subtract the y's, negative 5 minus 3. All right? Square root. 1 minus 7 is negative 6. Let's do this in our head. Negative 6 squared is 36. Let's do this. Negative 5 minus 3 is negative 8. Negative 8 squared, 64. Why is it not negative 64? Because negative times negative, right? If I square something, it's a negative times a negative, and that's always a positive, okay? So it's all going to be positive inside here. Check this out. Does that look familiar to you? Yep, square root of 100, which is 10. So this is 10, and what? This BC is also 10. So what kind of a triangle is it? It's a right triangle because it's got a right angle in it. But now we know two sides are equal to each other. So what kind of a triangle has two sides equal to each other? What is it? Isosceles. It's isosceles. That's right. All right. So that's pretty important. All right. We could do the third one as well. I'm not going to just because of time. Okay. But we could find that. But we did find that these two sides are equal to each other. And this means it's an isosceles triangle. All right. So that's pretty good. I'm going to do this example first, and I'm going to teach you a little theorem. So let me grab this. We're going to do a different set of sides. And I'm not going to find like the slope of all three sides and the distance of all three sides. I'm going to be kind of particular about which sides that I'm going to choose. All right. This is going to lead us up to the next big thing that we're going to learn in this lesson. So let's put the 3 points in here. So we've got point A. We got an A, B, and C again, right? It's it's the same one. It's the same exact one. Tell you what, I don't have to draw it all again. Let's do this. Let's get rid of all. Let's just get rid of this mess right here. I'll keep the triangle there. I'll get rid of this 10 and that 10. And so on. Get rid of that point. Okay, and then I'll get rid of this stuff. I'm already done with that. Whoops. Let's keep our 3 points there. I'm going to find one more thing. Let's get rid of this. All right. Let's go back to the same triangle. I thought we were doing a different triangle, but I'll just stay here. What I'm going to do now is something else. Look at AC. I am going to find the midpoint this time. Okay, I want to find the midpoint of AC. Do you remember how to find the midpoint? Okay, it's a point, right? So you put it in an ordered pair. It's the middle, so we divide by 2. Now go ahead. Right, now this is where we add, okay? And then you do the y's right here. Now I'm going to show you something that's pretty important, I think. All right? I'm going to find the midpoint of AC, and I'm going to find the midpoint of BC. I could have done any of the 3 sides. The example in the book uses this one, so that's what we're going to do. So I want to find the midpoint of AC. So here's A, here's C. So how do we find the midpoint? Well, just put your parentheses. Put over 2, put over 2. Again, I'm finding AC this time, okay? AC. So I'm using the first one and the bottom one. So what do we do? Add up the x's. Negative 7 plus 7. So what is negative 7? Well, we'll do that in a second. Negative 7 plus 7. Let's do AC again, but we're going to do the y's this time. So it's a 1 and a 3, and we're adding them together. 1 and 3. So now we're going to find the midpoint of AC. Negative 7 plus 7 is 0. 0 over 2 is 0. 1 plus 3 is 4. 4 divided by 2 is 2. So where's the midpoint? It's at where? 0, 2. All right? I already put a point there from the other thing we did, but let's make it in yellow this time so it pops a little bit. All right, so there's our midpoint right there. Now what we're going to do is find the midpoint of BC. And I'll show you why. All this is leading up to something, okay? I promise. Let's see, what time do we get out of here? I always forget. 38. 38. Oh, okay, good. I got time. I thought I was getting lower on time. So let's find the midpoint. That was AC, right? The first one we did. Let's find the midpoint of BC. Hope you guys are still with me. Some of you guys were never with me at the beginning, so. But that's your problem, all right? You can fail the quizzes and tests by not paying attention. That's up to you if you want. I would rather you not do that, but it's your choice. All right, here we go. Midpoint of BC. So what do we do? Add up the x's. 1 plus 7. 1 plus 7. Add up the y's. Negative 5 plus 3. All right. So 1 plus 7, that's 8. Over 2 is 4. Negative 5 plus 3 is negative 2. Negative 2 divided by 2 is negative 1. Okay. So what did I just find? What's that 4, negative 1? 1, 2, 3, 4, negative 1. Right there. See where it hits right on that line? That's the midpoint, isn't it? All right. I found two midpoints, didn't I? I could find the midpoint of AB as well if I wanted to, but I'm just going to stick with this one. What I'm going to do is I'm going to connect, everybody look, I'm going to connect those two midpoints. Now that little yellow line, that little line segment that I connected right there, okay, that has its own name. And we call that thing a mid-segment. Mid-segment. Okay? So there's our new word. Okay, we're all leading up to this. All that stuff we've been doing, all up to this, is to find the mid-segment. So mid means the middle, correct? All right, and that's what we did. We found the middle of this side. We found the middle of this side, or the midpoint, right? The midpoint here, the midpoint right there. We found those two midpoints. Now, what's really interesting is this. At least it is to me. It may not be so much interesting to you, but I think it's kind of interesting. That there's something that's true about this yellow one and the opposite side. What's the opposite side of that little mid-segment? Side what? Give me two letters. AB, right. So this AB, and I'll tell you what, I'll put it in yellow as well. Now, let's put it in a different color. Let's just make it blue. So watch. If I went from here to here, all right, see the yellow one and the blue one? There's something in common. In fact, there's two things in common with both of those. What is it? They look like they're parallel, don't they? Okay, would you agree with that? All right. How could I prove? How could I show that they're parallel to each other? Find the slopes of these two, right? Okay, so let's find the slope of this line. First of all, where is the it's at 0, 2, right? This is at 0, 2. And this point right here is at what? 4, negative 1. So let's find the slope of that line, because I want to see, is the yellow one actually parallel to the blue one? Looks like they are. Let's see if they are. All right, so let's find the slope. We've already done slope a couple times. Let's do it kind of quick. So we subtract the y's from each other. So 2 minus negative 1. Subtract the x's from each other in the same order. So what do I get? 3 over negative 4. So that's negative 3/4. Do you remember we found earlier, one of the first things we did was find the slope of AB? Do you remember what it was? It was also negative 3/4. I'm not going to do it again because we've already done it once, okay? Do you see it? So they're exactly the same. They're not reciprocals. They're exactly the same. This is negative 3/4. This is negative 3/4. So what's true about those two lines right there? The mid-segment and the side opposite. They're not equal, The slopes are equal. That means the lines are parallel, okay? So that just proved right there that this line segment and this line segment right there are parallel to each other. So a mid-segment has two things. What's the first thing that we just figured out? The mid-segment is parallel to the third side, okay? We'll say to the third side, right? These are the first two sides. Stop the humming, please. Let's pay attention. These two sides right here, okay, this would be the third side, all right? So that's one thing that we know about the mid-segment. What's another thing we know about the mid-segment? Well, let's take a look at it. If I pick this up, watch. If I pick, oops, if I can grab it. Where's that yellow one? Yep, look, if I pick this up and I put it there, what do you think a wild guess would be about the length of them? It's going to be half, right? From there and then to there. Do you see it? Okay? But let's prove that it is half. All right, so how can I prove that the length of the yellow one is half of the length of the blue one? Well, let's find the distance. Let's do it real quick. So let's do the yellow one. We'll do it in yellow. Let's find the length of the yellow one. So we've done this a couple times already, so we should be able to do it pretty quick now. So we subtract the x's from each other. So that's 0 minus 4. Subtract the y's, 2 minus negative 1. What do we get? Negative 4 squared. What's 4 squared? 16 plus, what's that going to be? 2 minus negative. That's a 3. 3 squared is 9. Okay. What's the distance? It's the square root of 25. What's the square root of 25? It's 5. Okay. So the length of that yellow one is 5. If we were right, what do you think the length of that blue one's going to be? Have we already found that? Look in your notes. Yes. Okay, I've erased it from here because I needed to make more room. But if you look in your notes, it should still be there. What did we find the length of AB to be? It was 10. So look, if that's 10, that's going to be what? 5. So let's get rid of this. It's got in my way here. What's the second thing about a mid-segment? Well, it's parallel to the third side, and it's also what? Half the length of the what? The third side, okay? So the mid-segment, two things that are true. It's parallel to the third side, and it's half the length of the third side. You with me? Now, that was a long way to go. I could have, and I really considered it. I really did. But I figured you guys could handle it, and most of you were able to. Some could not. But most of you were able to handle it. Figuring out that the mid-segment is both parallel and half the length of the third side. All right, so that was pretty good stuff. Let me give you an example. I think I saw some in the book. I'll probably put this in the homework. Let's see, what did I give you for the homework on this? Let me check the lesson plan. Just hang on. Let's do this example first. Let's see, Wednesday, 1 through 16. Yep. Oh, actually, for some reason, I don't know why I didn't assign these, but let's do this. Watch this. What if I had a triangle, something like this, and then, watch, I'm going to find the midpoint of this side, which is about right, if I could, come on. Why doesn't that click off of it? It ticks me off. There you go. Boom. Right there. And then about right there. All right, so what I did, I don't know if you could really tell or if you're even watching at all, but what I did is found the midpoint between this side and this side, all right? So if I connect the two midpoints, guess what I have? I have a what? I connected the two midpoints. So what is that red line right there? That's a mid-segment. That's right. So that mid-segment has got to be what to this third side? Okay, half of it, and also parallel to it. Very good. We just finished doing that, okay? So I'm just making this up. I was going to take a problem from the book, but I think that's a little bit more difficult. So what if I said the length of this was 10? Tell me something about the length of that one, x. You should be able to do that in your head very easily. That's right. So if I told you that this was 10, what would this one be right here? X must equal 5. It's as easy as that. All right? All that to do, all that distance formula and slope and midpoint, all that mess just to show you that this side right here was twice as big as this. Or you could say that this one was half of this one. All right? Don't you wish I would have just told you that in the first place and not gone through that nonsense? Well, maybe not, because I think it was good, okay? We kind of proved that this was true. It's not like I just made it up out of the blue, all right? You saw with coordinate geometry that this definitely is half of this, okay? I'm not just feeding you a set of lies, all right? So that's the kind of stuff that you're going to do. But it won't be that easy all the time. Yeah, what if I did this? And let's find the midpoint. The midpoint would be right there. And tell you what, let's just make them different colors. All right, so we'll make that one green, and we'll make this one blue. All right, everybody good with that? All right, we'll just call this ABC, just make it super easy. Let's make it white instead of blue. So this is A, B, and C. All right? So the red one is half of what? Give me some letters. Line segment BC. This red one is half of BC. What about the blue one? The blue one is half of AB. What about the green one? That's right. The green one is half of AC. Everybody see that? All right, so I could put some numbers in here and stuff like that. So what if I said, and we'll call this X, Y, and Z. All right? So what if I said that AY was 3? Then what is XZ? AY is 3. So if AY is 3, remember, these points right here are midpoints, right? So AC would be 6, because that would be 3 as well, right? Because it's a midpoint. So that whole thing would be 6. What's the green one then? It would be 3 as well, because the whole thing is 6, right? The green one is half of the whole thing. The whole thing is 6. Half of that would be 3. See it? So that means this AY and this XZ would be the same. This YC and this XZ would be the same. You got it? All right, same kind of thing throughout that whole problem. Yeah, I think that's good enough. On the homework problems, you will have to know how to find midpoint, distance, and slope. I don't know if you have to find midpoint. You will have to find the slope for sure, and you'll have to find the length, which is distance for sure, okay? So make sure the stuff that we did earlier with that slope and distance, you remember how to do, because you're going to have to do a couple of those for your homework. All right, and then I'm going to give you a worksheet on this stuff tomorrow, okay? Well, actually not tomorrow. Oh, I'm going to give you that 19 to 30. Okay, I figured I gave you those things. So we're going to make it a little bit harder tomorrow, but it's the same exact lesson, just the problems are a little bit more difficult. So the ones we're doing today are pretty easy. It's 1 through 16, and it is pages 196, 197. All right, and this is section, what is it, 4-7? We'll call it A, because I'm going to give you a second part to do tomorrow, okay? So this is A. Tomorrow I'm going to give you part B. On Friday, I'm going to give you the worksheet, okay? Friday, I'll give you the worksheet, but this is the first assignment for 4-7. All right. You got almost 10 minutes, okay, to begin this. Okay, you should be able to get several of these finished in those 10 minutes. Don't just look at it and say, well, it's almost over, I'm just not going to do anything. It wasn't a suggestion. Everybody's listening, right? I have the normal suspects not listening. Not really going to talk to me, are you? So, I want you to start it now, okay? It's not a suggestion. I'm telling you, you need to start working on it right now. So get your book out, get your notes in front of you if you need to look at your notes, get a loose leaf piece of paper in front of you to start the homework, label it first, put your name on it, and then start working on 1 through 16. And that'll be due tomorrow.